What we're going to work on now is the use of the spectrophotometer. This is the spectrophotometer we're going to be using. There are plenty of different models out there, but they all work basically the same. Okay. This is called a Spec20D. The D means the display is digital rather than analog. This machine has been around in one form or another for over 50 years. There are plenty of versions of this thing from the 1980s that still work beautifully. So it may not be the newest thing out there, but it works well. You've got to understand all the parts and how to use it. It's not difficult, but it's not necessarily obvious. First thing, it really doesn't even have an on-off switch. You turn it on with this knob down here. So there's the on-off switch, and we can see it's kind of come on. You want to let the machine warm up 10 or 15 minutes before using it. The light bulb that's going to give off the white light takes a while to heat up. Most of the time, this will be pre-warmed up for you to save time in class. So let's look at the things on the machine that you're going to be working with. There are some other functions we're not going to be using, so we're not going to worry about them. When you want to adjust the wavelength, you use this knob here, cleverly labeled wavelength. So here's the wavelength display. So you'll notice as I turn the knob, the wavelength changes. This is a visible spectrophotometer, so it's going to primarily be operating in the range of about 400 to 700 nanometers. There are other spectrophotometers that use ultraviolet or infrared light. They're going to work essentially the same way. A visible light one's a little easier to understand because it's dealing with things we're used to seeing. Your sample, technically called a cuvette, goes in here. It will only accept one size test tube, and it just plops in. Always do the reading with the cover closed to avoid any stray light getting in. You'll notice that on your cuvette there's an arrow. And the reason for that is, if you're using one of these, you always want it oriented the same way when you put it in. That way, if there was an imperfection in the glass, a smudge, or a little scratch, it would be constant when you did your blank, or essentially your control. One of the first settings you'll have to do is a 0% T. And you'll see an example of reading a sample shortly, but here's the 0T knob. One of the things that seems odd to people about this machine is the knobs can sometimes go either way, and they can go around more than once. Doesn't matter, you'll get the hang of it as you use it. When you want to use your blank, you use the 100% T 0A dial. And this just can turn around multiple times. Okay. When you want to change from transmittance, how much light goes through, to absorbance, how much light is absorbed, you use the mode button. So I'm going to go through the mode. These other two possibilities don't apply to us. Transmittance, absorbance. Both with the mode button. And there'll just be a red light to show you which one you're using. The wavelength you're using will be shown here, and the absorbance or the transmittance will be shown there. If by chance you need to adjust the filter, you just flip this switch. Okay? That won't be a part of our lab here, but there's certainly plenty of labs where it is. Reading a sample using a spectrophotometer. The first thing I'm going to do is select the wavelength I want to use. In this case, I'm just going to choose 550 nanometers. So I've got that set. Then I'm going to set the machine to 0% T and there'll be nothing in the sample. So I just turn the knob until it reads 0. And what I'm essentially doing here is I'm basically saying to the machine how much light is passing through this area here when there's nothing in the way. Then I'm going to shift to absorbance mode and put in what's called a blank. In this case, it's water. So here's my water, and the reason I'm using water is my sample is dissolved in water. And even though water is transparent to us, it does absorb different wavelengths of light differently. So I put my sample in, close the cover so no stray light comes in, change it to absorbance, and make it read 0 with the 0A knob. Okay. Which way do you have to turn it? You'll only know when you try it. There's a little bit of a lag on the machine. So when you turn the knob, it'll take a second or two to stop moving. And once you've used the machine a little bit, it's pretty easy, but it's not always obvious how it's responding. So I'm just going to turn this till it reads 0. Now we're out there in the thousands place, so sometimes it'll read 0.000, sometimes 001. It's not really going to be a big deal. It's a little tedious the first couple times. There we go. So now the machine essentially knows, and you'll notice my wavelength actually shifted to 551. I can change it. And let's get this back to 0. There we go. It's probably about as close as we're going to get. So now my machine essentially knows how much light does the glass cuvette and the water absorb. I'm going to take that out, and the cuvettes are made to be almost a match. So they're all made very consistently. Here's my sample. I put it in, close the lid, get my reading. So it's empty, 0% T, change to absorbance, put your blank in, 0A, sample. Every time you change the wavelength, you have to go through that process. If I didn't change the wavelength, I could just put my second and third samples in. So that's how you actually use a spectrophotometer. Beer's law. Beer's law describes mathematically the relationship between the absorbance of a solution and what's called the molar extinction coefficient, which is essentially a constant for any given chemical. So for example, this chemical and this chemical would have a different value of the molar extinction coefficient. In this lab, we're only using one chemical. There's only one chemical that's going to absorb light, so epsilon is a constant. Okay. L is the path length. That's essentially the size of the tube we're using. We only have one size tube. That's also a constant, but you can kind of see the effect of that here. If I hold this up this way, you can see that it looks a certain darkness. If I rotate it, it looks a lot darker. And that's because when I hold it this way, the light is basically traveling through a couple centimeters of blue liquid. But when I hold it this way, it's going through 10 or 12. So it's going through a greater path length, which means it's encountering more molecules that can absorb light. That's also a constant. So in this lab, absorbance is equal to 2 constants times the concentration, which means absorbance is proportional with concentration. For the units, path length is in centimeters, concentration will be in molarity, and the molar extinction coefficient will end up in 1 over centimeters times molarity, which means absorbance has no units. So here's an example of concentration. Here's 1 molarity of green liquid. Here's a higher molarity. These tubes have the same path length. They're the same size container. So here I'm actually seeing Beer's law. This one will absorb more light than this one. And that's essentially what the spectrophotometer does. It puts out a consistent amount of light, and it measures either how much light is transmitted, goes through, or how much light is absorbed. We tend to prefer absorbance because it gives a linear relationship, which is a lot easier to work with. Pipetting. In this lab and in several others, you'll need to accurately measure some fairly small volumes. There are two types of pipettes you might see. The first is an old-fashioned bulb pipetter, so I'll show you how to use that. And the second is an automated one. So this is a pipette bulb. If you squeeze it and push this button at the top that says A, you'll notice it compresses. I'm going to put a pipette into this. It doesn't have to be wedged in there. As long as you can do this, it's good. I'm going to use a sample of blue water. I just put some food coloring in. I'm going to put the tip below the water level and push the S button. And you'll notice the liquid comes up the pipette. I can read the volume. So right now I've made it read 0. If I let out to 1, I've let out 1 milliliter. And the E button is for empty. If I go from 1 to 3, now I've let out 2 milliliters. And these are marked off every 1/10 of a milliliter, so I can measure to the 100th. With an automated pipetter, it works essentially the same way. You take it off its charger, put this in a little tighter, hold it below, the up button brings it up, so that's essentially the suction. The bottom button releases the liquid. And that's all there is to pipetting.